What we're starting today is chapter 6, exponential and logarithmic functions. Well, yep, it's not going to let me do gestures anymore. What we're looking at first, I'm going to keep throwing this, is exponential growth and exponential decay functions. Now, an exponential growth and exponential decay function of one are almost the same exact function. We have this b to the x, or y equals b to the x, and it's considered exponential growth if b is greater than 1. If the value b is greater than 1, it is considered to be an exponential growth function. And it's going to increase exponentially. Now, clear? So if we had, say, 8 to the x, and I graphed it here, it increases faster and faster. Now, it's kind of hard to see on a graph, but if we look at the table, well, it goes 1, 8, 64, 512. Well, within 4 numbers, we're in the thousands. Now, 9. By the 10th number, what we have is 107. 1,070,000. So by the time we get x equals 10, we've already hit the millions. That's why they call this exponential growth. It's increasing exponentially. If you've ever heard it mentioned or talked about in kind of different, I think they'll throw it out in kind of TVs or movies, like the plot increases exponentially. It's growing fast is what they're talking about. It's increasing exponentially. It's growing. And it keeps growing faster and faster from one number to the next. So whenever b, this value here, is greater than 1, it's considered exponential growth. Now, if b is between 0 and 1, it's considered exponential decay. Now, exponential decay is used in science in something called half-life. Does anybody know what a half-life is, or what it's referring to? Because it's not referring about gaming. It's actually in chemistry. It's talking about radioactive elements. Because the half-life describes the amount of time that it takes for a radioactive element, so uranium or radon, to become stable. So it's not emitting radiation at any point. And unfortunately, it takes a very long time, depending, some not as long as others, but it's still a substantial amount of time for half-life, especially radiation, to decrease and completely eliminate. So another side fact, does anybody know who found one of the first types of radioactive elements? It was actually not Einstein. It is Madame Curie, female scientist. She ended up, her and her entire family actually ended up dying of radiation poisoning because they didn't know what radiation was at that point. Her books and everything, all of her material actually in lead encased. Everything's in lead encased because even today it's still radioactive, and she found, I think most of it was in the 1950s. So it's been 60, 70 years and it's still radioactive. The reason they ended up having that is because they found it very interesting. Essentially, it was a rock that glowed no matter what time of day. So they found it curious. She gave her husband a big one that he had as a paperweight on his desk. Hindsight's 20/20, but that's half-life. It kind of tells us how it breaks down. So we have these here. Now, let me keep doing that. So let's look at these first two here. So the first one we have is y equals 2 to the x. Now this here would be what? Growth or decay? Because A is bigger than 1, yes? So this would be growth. Because our B value is greater than 1. Now if we were to graph it, we can plug points in to try to graph it, or I can come over here and do y equals 2 to the x and hit graph, and it'll graph it out. Now, on the homework, it is going to ask you to pick the correct graph. For exponential growth, when x is 0 and x is 1 are going to be 2 key points. Because when x is 0 for this here, the value of y is what? 1, yes? Because anything to the 0 power is 1. Now, when x is 1, the value of y is 2, yes? And it'll work out that way almost every time for exponential growth. So if I change it to 9, well, when x is 0, it is 1. When x is 1, it is 9. So it kind of helps us see.
I can't get it to graphic because I got 2x. I push graph.
Hit zoom 6.
Thank you.
You're welcome. So if your graph for some reason is not graphing well, zoom 6, what that does is it zooms standard, Z standard. It's resetting the graph, the axes, for the x to be negative 10 to 10 and the y to be negative 10 to 10. Okay? So it's a good way to fix the graph to go back. Any questions on this here? We got a good with this here? Yes. Now, if I wanted to evaluate this for, say, x equals 2, well, we could just do y equals 2 to the second, which would be 4, yes? If we want to evaluate it for a number, we can just plug it in for x. Yes? Okay. How about B? Is this going to be exponential growth or exponential decay? Because our value of B is less than 1. I didn't want to type in 1/2, but 1/2 is the same as 0.5, yes? So if we look at the graph for this here, it is going the other direction, yes? And if we notice this here, the values get smaller and smaller and smaller and smaller, yes? Going all the way down. Because the value, let's see, because we can look at the graph. Well, you can see it starts big and then it gets smaller as it goes to the right, yes? Now the question is, will it ever be less than 0, or will it ever equal 0? Well, really, this is the same as 1 over 2 to the x, because I can apply x to both the top and bottom. I don't apply it to the top because 1 to the x is always going to be 1. No matter how many times I multiply 1 by itself, it will always be 1, yes? And as we saw in the first one, or this one here, 2 to the x is going to get huge as it continues out, yes? So what this is doing is that the numerator is staying 1, but essentially the denominator is becoming infinite. But essentially, if we take it far enough out, it would be an infinite number, yes? What is this number really close to? Well, 0, yes. As the denominator gets bigger, it's getting closer to 0. Wait a minute. The only way that this can become 0 is if the numerator is 0, yes? Will the numerator ever become 0? Well, no, it's just 1, yes? So would this fraction ever become 0? Well, no. So this here, on both of these, they will get close to 0. For all intents and purposes, they will be insignificantly close to 0. Mathematically speaking, we call it 0 plus. It's so infinitely close to 0, we call it 0 plus. It's just a little bit more than 0. But it will never reach 0. Neither one of these will reach 0. So it's an asymptote at that 0. Okay? Is there ways to make it equal 0? Well, yes. I can subtract 1 from it. I've moved every value down 1, which means that this function here now, it'll cross 0, it will never reach -1 because I've moved that asymptote down 1. So we can manipulate them in some ways. Any questions on this here so far? How about this one here? Even though it has a decimal, it's still greater than 1. Because it's greater than 1, it is still a growth. It's still increasing. And I have a feeling y'all are good with finding graphs, because we can plug it into the graphing calculator and it'll kind of tell us which one it is. And with growth, I would really look at 0 and 1. With decay, I would look at 0 and -1, because it gives us that nice solid value on the other side, because it's coming down. How about this one here? What would this one be? This would be decay because the value of b is less than 1. Any questions on any of this here?
What if it's less just 1 and less? Is it still decay?
So we can use this one here. So this one here would be growth, yes? Well, I didn't write. It doesn't. I put the pen down. This here would be growth. So you're talking about, like, say, y equals -4 to the x, yes? So what would this one be? And I'm not writing again. This would be growth. Because really what we have here is not in the form y equals b to the x. What we actually have is y is equal to a times b to the x. Because if you notice with most of the formulas that we've come across, they really like starting with a. Because alphabetical order, they like go A, B, C, D. We always like starting at the beginning. That's partially why this is starting out at B. Right, so we can really look at this as y is equal to -1 times b, or our 4, to the x. And we can have any other number besides 1. Now what this has done is it's taken the function. I don't even look at it. So y equals delete 4 to the x, -4 to the x. These two functions. It's still considered a growth, but it's across the x-axis. Because if I'm remembering this correct, it's just considered a growth. We're just reflected it across the x-axis, because as is decreasing, it's increasing more in the negative direction. Because really we look at it as the absolute value, because we actually can't have a negative inside the radical. is if I try to graph -4 to the x, it won't graph it. But it will tell me what the values are. Because we have this here. Now, if you notice something's weird about the numbers, because at 2 it's at 16, at 3 it's at -64. 256, -1024, 4096. It's going positive, negative, positive, negative, positive, negative. And this here is I had the term this morning. I don't know, it's going to come back to me. Because this function is essentially switching as it goes down. And the term will come back to me probably in about 10 minutes. But this kind of function would not be considered exponential. So it's not considered an exponential function because b cannot be 0, or negative. B can't be negative. Does that make sense? So that's, any questions on any of this here? Are we okay with this here?